Hello and welcome to today's class. I'm still Sajid on Extreme Learning website lecturing, and today we have a problem posed by students. We are given a universal set x such that x is an element of an integer value, and this it ranges from minus 10 less than x less than what 20. So this is the universal set given in the problem, and then we have a set A such that we have x such that x is an element of a natural number n, and this x is less than 10. That is the element, right? And we have a last that is another set x such that this x is element of what? An integer value, and it runs from minus 7 less or equal to x less than 15. Okay, and then the first problem we're asked to find in this set is to find A intersection B, and the secondly we are asked to find A intersection B what? Complement. So this set problem is quite easy, as I'm going to explain a couple of things for us here. For example, I want to start by defining what an integer value is. Now, an integer value is simply a set of both positive and negative whole numbers, of which if I say whole numbers, you know what whole numbers are? Numbers that stand alone, that are complete set, not fraction, right? Not decimal. So that means integers, we said they are both set of positive and negative whole numbers, so they start from negative. They also have, for example, minus. I can start from minus 5, minus 3, but I want to start from minus 1 closely to 1, so all those things 0. And I can just continue putting this dot, which means till infinity. Infinity, that it can go to positive infinity, and it starts from negative infinity. So this is what we call what? Integers, right? So next, in the question, we also refer to something called natural numbers. Now, natural numbers are simply the set of counting numbers. In mathematics or any real life situation, if you are given object to count, you surely will start from 1, 2, 3, 4, continually up to the last term. That is the positive infinity of the number. So you see that natural numbers, just like from the word nature, is actually this in this way, right? You count forward. So that is what we mean by this. So that means we've now understood what these two terms that I referred to here means: integer and then natural numbers. Next, let's try to expand up what this U actually is defined to be, what it means by definition, and then we also examine what A is by definition and what B is by definition. So now let's quickly do that. Now our set U, recall that our set U was given to be x such that x is an element of what? X is an element of z, which is an integer, and it is run from minus 10 less or equal to x less or equal to 20. So what this means, since this is an element of an integer, so it means that U is equal to, is going to pick from this number 10, that is from minus 10, minus 9, minus 8, continue minus up to minus 1, 0, 1, 2, continually like this, right? So not up to minus, let's say 8, not minus, sorry. Not minus. Remember, this is 1, 2, 3 continually up to, this is 18, 19, and then 20. Remember, it is less or equal. So this becomes the element of U. All these numbers are now the element of U. You can list them if you want. Whenever you see me put dot, 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 it means continually. It's a sequence. It's a sequential stuff, right? So that is U. So we're going to use this element for U when trying to work on this problem. So the next thing is, let's look at set A, which is defined to be x such that x is element of a natural number, and this x is less than 10. Okay, very important. So remember what natural number is. We said they are a set of counting numbers. So that means we're going to say if this is natural number, so A is going to include what? Numbers that are less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We can stop at 9, we can stop at 6, we can stop at anything, since it is what? Less than 9. So this becomes the numbers we're going to use for A. Now let's move ahead and check for set B. Set B is a set defined such that x is an element of an integer value, and it starts from minus 7 less or equal to x, then less than 15. Remember, if you see less than 15, it means 15 not included, right? So if we also check, since element of Z, we know that Z is set of negative and positive whole number. Thus, we know that B is going to be having elements from -7. -7, -6, -5, -1, 0, 1, 2, continually up to 14. Remember, 15 cannot be among. Yes, it can stop in 10 because it's actually less than 15, but not 15. So, but let's use just these whole numbers, these complete numbers, in order to solve our problem. Now, let's attack the problems one after the other. The first one here, we have that the problem says we should find A intersection B. Now, in set, this thing called intersection simply means the common elements, right? So we're looking for elements that are common to A and B. So now first, let's write out A. What are the elements of set A? Now the elements of set A are 1, 2, 3 up to 9. So let's go for it. 1, 2, 3 up to 9. So that means set A has 1, 2, 3 up to 9. Please don't misinterpret this. This is up to 9. Now what about set B? Set B has from -7 up to positive 14. So that is from -7, -6 up to positive what? 14. Of which, if you check, you know that B actually swallows up A. Yes, because all the elements in A, which are from 1, are all contained in this. Because if you are tracking from -7 to 14, you must actually come across 1, 2, 3, 9, and the rest inside of, and so it is inside of B. So this is set A and this is set B. Now we said that intersection simply means common elements. So if you check, what are the common elements? Of course, 1 that is here will be found in B, surely. 2 will also be found in B. 3 will be found in B since it's up to 14. Even 9 completely will be found. So everything in A will be found in B. It simply means where the two of them intersect are actually equal numbers of elements in A. Thus, their intersection, we can write them as A intersection B is actually equal to 1, 2, 3, 4, 5, up to 9, right? And so if you check, this is just equal to A. As simple as that. And we're done with the first one. So that is what we mean by that. The intersection, where it intersects. So next, we want to find this A intersection B complements. When we say complement, we're actually referring to set U minus A intersection B. Good. So that means every element in A intersection B, we're going to remove it from the element in U. Fine. Now let's check. What are the elements in U? If you examine, you check that elements in U are actually from -10 to positive 20. So let's look at something. If element in U runs from what? -10 to positive 20. And we want to remove A intersection B, which is what? From 1 to 9 from this U. What do you think will happen? It's just like saying, if I come in between this, remove 1, 2, 3, 4, 5, 6, 7, 8, 9. So what number do you think will remain? Of which, of course, you know there will be -10, there will be -9, there will be minus up to -1, every negative will still be there, there will be 0, but there will not be 1. There will not be 2, there will not be 3, there will not be up to 9, but there will start be from 10. We'll start having from 10, 11, up to we reach 20. So this becomes the solution to the problem. Very simple. So here we now see that we have successfully gotten what? Our A intersection B complement. Thanks for watching the video. You see, it's very nice and it's simple. So let's check out the other video on the other solution.